Hey guys, welcome to the channel. Today I'm going to do something new. It's a little hybrid format that'll have a pre-recorded piece and then we're going to go live. And during the pre-recorded piece, what I want to do is just kind of cover the quick ins and outs of the Matek F722-WPX, which I have right in front of me. And then in the live session, we're going to plug it into the computer and I'm going to show you how to go through the initial setup process and then the things you'll encounter along the way as you work on configuring the F722 with iNav. So the first thing I thought I'd do is give you some quick measurements. I've already gone over the hardware specs and I'll link to that in the video so you have that information. I'm not going to cover the hardware specs today, but I do want to give you some dimensions and weights just so you can get an idea of what's going on with this board. So in terms of width, we're looking at about 29 millimeters. And then on the length, about 43 millimeters. And then this board is just a mounting board, so it screws to the standoffs. I'll show you that in a live session, but that screws onto the standoffs. All right, next up is the weight, and I'm going to use not just the flight computer, but I'm also going to use the remote USB daughter card. And then finally, I'll stick the pin headers on there. So about 24 grams with the GPS, and then this setup, I'll be using a BN220, 31 grams. The first thing I do to get a 722 WPX ready to go in a plane is to install the pin headers. It's very helpful to get the diagram off the Matek website on where those pin headers belong. I'll just set this wiring diagram right in front of me as I solder, and that way I'll have a nice reference as I move along. Personally, I like to work from the inside out, so I'll start with the inside pin header and the most difficult to reach pin first, and then I'll work my way to easy. Okay, enough of this. All right, I've got my pin headers installed. Let's take it inside and connect it to the computer. All right, guys, now we're live. So that was just a little pre-recorded bit that I wanted to do to give you an idea on the initial out-of-the-box part where you have to do the pins and get the pins soldered on. Personally, I like the pins better. I know you can solder directly to the board if you want to. And the reason I don't like to do that and the reason I like to have the pins is because with the pins, I can make adjustments. So I'm going to switch over to the big camera. And I want to give you a close-up look. I mentioned in the pre-recorded piece that I would show you the standoffs, but I want to show you some of the wiring first. So I'm just going to zoom in and we're going to focus on the wiring connections that I've made just ahead of time, just to save a little time on the live stream. So the first thing is the GPS puck. And as I mentioned, I'll be using a BN220 and I'm using UART number 2. And I'm going to bring up a website in just a minute to show you guys where the I'm getting a YouTube error, of course. I love YouTube. Anyway, I'll bring up the Matek website in just a little bit to show you where the wiring diagram shows that these connections go. But the bottom line is I'm using UART. I think this is UART 2. Nope, this is UART 3. Let me bring up the website. I have it here. So let's switch over to the main desktop. And there we go. So the GPS, let's see, they say any spare UART, and I have it connected to number 3. And then I have the receiver is connected to UART number 2. So the main thing to remember about the GPS is that you want to have your ground and power, of course, that's normal. But then you also want to have your receive and transmit flipped. So when you have a receive on your GPS, you put that on the transmit on the board. And then when you have transmit on the GPS, you put that on receive on the board. So I'm going to go back to the big camera so you can get a better look. Okay, so you can see that I've got my black ground for the GPS there, my red power for the GPS there, and then the very first pin is after power is the RX. So that is going to be TX on my GPS. And then the last one is TX, which will be RX on the GPS. So that's the GPS. And again, you can connect that to any open UART you have. I just connected mine to UART number 3. As far as the receiver goes, I get this one a lot. When I do Crossfire, it's real easy on Crossfire because the Crossfire diagram is also on that wiring page, and I'll go back to that at some point. But on the Crossfire, you've got channel 1 and channel 2, and they go to RX2 and TX2 respectively. It tells you right there in the diagram. But because this time I've got my little 161 receiver from Radio Master, this is an S-Bus receiver. I'm going to be doing telemetry over S-Bus, and my signal protocol will be S-Bus. So you can see on this diagram, same thing as the GPS. I've got ground right here on this pin, power is the next one, and then signal. And then notice that this pin is connected to this little purple wire. And when you look real close on the receiver, see if I can get this to focus, you can see that that purple wire is the S-port wire. That's the FreeSky S-port wire. So all I did was connect a servo lead to that wire, and I put it on the TX2 pin for the UART RX2 or UART2. Okay. Now I'll show you in the setup what this means and why we do that. We do that for telemetry. So if you want to get telemetry, all that wonderful board telemetry that comes off this flight computer, take your S-port connection and just connect it to the TX2 pin next to your receiver. And I'm going to be using soft serial on this one. And by using soft serial, that lets me preserve this last remaining UART, which is UART number 5. Okay. So that's all I've got wired up so far. I've got the GPS that's connected right here. We just covered that. And then I've got the receiver, which is the standard 3 wires, negative, positive signal, and then the addition of the S-port, and that's on TX2. The only other wiring I have is an XT60 for power, and I've got the USB daughter card right here. Now, before I go any further, if you guys remember, I just did the video on the ViFly or VFly smoke saver. We get a chance to use that. So I haven't powered this up yet. I did power it up before I soldered pins on to make sure the board worked, but I haven't powered this up yet, and I really want to try this smoke saver out because this little device, this is where this thing earns its money. Okay, so when I soldered everything, I did the visual inspection, I checked with my multimeter, but again, it's easy to miss things. So I'm going to use my smoke saver to make sure that I don't have a short circuit somewhere on this board. So you can see that I've got my smoke saver or my short saver plugged in on the input for the battery lead on the Matek board. Now I'm going to connect my input battery. So I'll turn that on, and you can see that I've got the yellow light, which means it's good to go. And this is the power button. So now that everything's ready to go, I'm going to go ahead and hit the power button. And as long as this goes green, that means everything on this side is okay. So here we go with the very first power on of this board. Okay, I got an RSSI alert because I've already bound this receiver, so that's why we got that alert. But there we go. We got a nice clean startup, no smoke. That's a really cool feature. So now that that's done, we can disconnect this thing and get it out of the way. But I'll tell you what, man, that right there just takes a lot of load off your shoulders the first time you fire one of these things up. I'm really glad to have that. That's a nice little tool. Okay, so now that that's done, I don't need the battery just yet. The reason I got the battery wired and ready to go is because I want to show you some things on the FreeSky OSD, the Pixel OSD, namely how to upgrade the firmware. And in order to really show you what you get by doing that, I needed to have a VTX ready to go. So I've got one ready to plug in. We'll get to that a little bit later, but we have a couple of other things that I want to do first. So the first thing we'll do, now that we've got the board confirmed working with powered input. We've got our daughter card connected, our receivers connected, GPS is connected. Now it's time to connect the board to USB. But before I do that, I'm going to flip over to the desktop because I want you guys to see iNav. All right. So I'm going to bring iNav up now. And oops, I already have it running. There we go. And I'm going to hide the wiring diagram. We don't need that at this point. So here's iNav, and the very first thing that I'm going to do with this board is I'm going to plug it in and show you the version number. So hopefully you guys can see iNav okay on the screen. I've got it scaled the best I can, but I'm going to go ahead and plug this USB-C connector in, and you can see I've got power. I'm going to turn the radio down because she keeps talking over me. Okay, so I've got power to the USB daughter card. The iNav computer is fired up. And now all I have to do is hit connect. And I should get a connection. And I'm going to go to the CLI and I'm going to type version. Whoops. Okay, so version 2.5.1. Now, that's not even close to the latest. So I don't want to run that. I'm going to erase that. And the way we're going to do that, this is an important step. When you first get one of these computers and you want to update your firmware, I'm going to use 2.6.0 because I know that firmware works. I've got it on other Matek F722-WPX computers. So what I'm going to do now is disconnect the flight computer. And there's a little button right here. And that puts this thing in what's called DFU mode, which allows you to write firmware to the chip. So what you want to do is press that little button. And with that button pressed, plug in the USB cable, and you should see in iNav, this mode up top right here changed to DFU. Okay, so in DFU mode, that's where we're able to go and select the firmware that we want to install on the board. So I'm going to go to firmware flasher, and then I will choose the Matek F722-WPX, which is right here. And then I'm going to select firmware version 2.6.0, and I'm going to go ahead and do a full chip erase just to make sure we have everything starting from scratch. Okay. So next thing we need to do is load the firmware online, which basically is telling iNav pull down a copy of the firmware. So we're going to do that by clicking on load firmware online. And now that's how fast it came in. It's already downloaded. Now we just hit flash firmware. Leave it alone. Let it do its job. Let it do its thing. Normally when you make production videos, this is the kind of stuff that either gets sped up or cut out. So you guys, when you don't see this kind of stuff when I do production material. Real quick, I just want to say hi to Martin and Lynn and David and Formula Mazda. Philip, how you doing? And Hola Achillin, how you doing? MS Aviation, glad you guys could make it. Yeah, if you're on the stream, make sure you chime in and say hello so I know who all is there. Okay, rapidly approach the back of it. Programming successful. Now we can hit connect, and we hit connect. Sometimes it works, sometimes it doesn't. Sometimes you just have to unplug it, and it looks like I'm going to have to unplug it this time. So I'm going to go ahead and unplug and then replug. Yeah, it's still being a little bit stubborn. Okay, let me just unplug it again and let it fully cycle. And I'm probably going to go ahead and cycle iNav too real quick. So give me just a second. Cycle iNav. The configurator is what I should say. Okay, and now we'll plug it in again. This is the nature of open source. Sometimes you deal with little weird things like this. There we go. Okay, you notice how it's asking for default values right off the start. It's saying, hey, what are you going to use this for? Are you going to use this for a mini quad or an airplane or boats and rovers? In my case, this is going to go in the Strix Goblin, so I'm going to hit airplane. And now it's going to reboot again. Yeah, Martin, isn't that funny? The blinking LEDs. I already had blinking LEDs. Didn't want to restart. Okay, now that we've got a restart, I can come over to the CLI, and I'm going to close my Chrome browser just to give me a little resource back. But
We're back in the CLI now, and I'm going to type version again. And there you can see we've got 2.6.0. So that's how we know we've got the right firmware. All right, so everything's good there. Okay, the next thing I want to go to real quickly is I want to do the telemetry setup for you guys, because I want you to see how easy it is to do telemetry on these things. So I'll go into ports, and it does do a reboot automatically when you leave the CLI now, so it's not surprising. That's not a bug that it did that. I'd like to see it reconnect automatically, but when you leave the CLI, it does reboot. So I'll go into ports now, and here's where we get the telemetry. So remember earlier, I talked about that FirstKey S port, right? Or that FreeSky S port. That's this connection right here. So we're going to use soft serial for that. And under the telemetry section on the ports configuration, I'm going to go ahead and select smart port. I have this right? Smart port. There it is. That's the one I want. So once I do a save and reboot on that, that'll configure that soft serial TX pad to send telemetry. Okay. So let me just go over to the receiver tab and make sure we've got receiver working, and we do. So I'm moving my sticks on my radio, and you can see I've got movement. So that means my receiver's working. Now I'm going to move all the stuff out of the way, and I'm going to switch over to the big screen real quick. And as you can see, I've got a Strix Goblin model set up. This is the basic iNav template that I use for all my planes. So I'm just going to hit model, and then I'm going to hit page left. And you can see I've got no telemetry sensors in here. So I'm just going to click on discover new sensors. Oh, you know what? I forgot something in iNav. Hold on. In iNav, I forgot, under configuration, you do have to turn on telemetry. So let's see here. Telemetry output. Well, I can turn my GPS on too. Oh, you know what? Under ports. See, again, this is when you do edits live. You get rid of all this nonsense. So there's GPS. I want to turn that on. I've got smart port enabled. I wonder if that should be FreeSky. I'm going to leave it on smart port for now. I think it should be smart port. Let me do a quick reboot. It didn't save. So let me reboot it again. All right, what am I missing here? I wonder if I have to enable soft serial. I'm missing something. It should be smart port. That's what I think it belongs on. And I know I've got that connection on there the right way. That should populate instantly. So I'm missing something. I might have to revisit that. Might have to come back to that at some other point. But that should be working. Let me just check one other thing real quick and make sure that I've got soft serial enabled. Air mode, advanced. Yep, I'm definitely missing something. Serial, S-Bus. Yep, I don't know what I'm missing. I may have to skip over that. I may have to skip over that one and come back to it at some other point. But I know that that's the way it's supposed to work. So I'm not getting, the weird thing is I'm not getting any telemetry at all. So that's kind of odd. I'm not getting anything. Let me just power cycle iNav real quick. That was weird. Look at that. They popped right in there. So I'm not off my rocker after all. Let me switch over to the big camera now. There we go. So we've got at least some telemetry information, but for some reason it's not populating. So, but we do have sensors, and let's see. Yeah, that's showing. All right, let's see. Now maybe back under ports if I need to switch over to Free Sky. No, it says Smart Port. Let's just try Free Sky for the heck of it. It's interesting to me that I got some values here, but they're all in red. So I'm really not sure. I'm really not sure what's going on with that. Almost wonder if it's a radio issue. Hey, by the way, welcome to flight computers. You know what I mean? This is kind of like one of those things you deal with. Eventually you get it working. Okay, so I've got some values, but not a lot. You can see I've got TRSS, I've got RSSI, so I'm kind of thinking that's not correct. I'm still thinking that's supposed to be Smart Port. Yeah, there we go. Now everything's in black. I wonder if we get the... what I'm looking for is if we get the movement on the flight computer. Yeah, we do. Okay, so if I back out of this now and hit page right to my Lua script, yeah, you can see I've got an error message saying not okay, but I do have RSSI, so I do have some telemetry coming in here. There it goes. You can see I've got the AHI working, so that means I've got telemetry. I think the not okay just has something to do with the fact that I don't have it ready to arm yet, but there you go. We've got telemetry because that AHI is moving. So it looks like SmartPort, not Free Sky, it's SmartPort. Okay, so that's it. I just wanted to show you the telemetry does work, and then so what we've got so far, let's go back and just kind of recap what we've accomplished so far, which may not seem like a lot, but we've got our receiver going, we've got our telemetry going, and OSD. That's the next thing I wanted to show you, because before I get into the flashing of the Free Sky OSD, one of the questions I get from my videos quite a bit is, how did I get the screen to show the boxes that I have? So what I'm going to do is I'm going to take the computer, which is just sitting here wired. I'm just going to move it out of the way. So I'm just going to set it out of the way and put it off to the side a little bit. And when I want to bring my monitor in, bring the monitor in so you can see the monitor. And I'm going to hook up my VTX. So I want to connect the VTX. And the reason I'm doing that is because I want you guys to see what the OSD upgrade looks like after you've done the work. I just have to find the channel that this thing is on. I may have to reboot the flight computer again too. I don't know if it likes having the transmitter plugged in after the fact. I don't think it does. So give me a second. Let me just reboot the flight computer real quick. I don't know why I'm not getting a screen here. Yeah, that's kind of funny because I did actually check this, believe it or not. Oh boy. Computers, right? It's going to fight, man. This is iNav. It fights. But it sure seems like it wants to lock in there. I don't know why it's not. Let me, I guess I'll just plug in the board and we'll go through the steps I was going to go through anyway. Maybe at some point I can get the OSD to pop on the screen. Okay, the whole point in doing all this was that I wanted to show you guys what the on-screen display looks like by going through the configurator and showing you, let me switch over to the desktop. So when you look at the on-screen display, this is the default out-of-the-box configuration. One of the big questions I get is how do I get the scroll bars on the right and left? So right here on the left side scroll bar, I normally set that for ground speed, and on the right side, I set it for altitude, and then I hit save. And when I do that, with the correct firmware, it will display. But right now, it's not displaying because we don't have the right firmware. So what I'm going to do next is I'm going to disconnect, and I'm going to close iNav, and then I'm going to bring up the FreeSky on-screen display. And I wonder if maybe, no, that's not running, so that's not the problem. So here's the FreeSky on-screen display. And before I go through any flashing or anything, I'm going to do a full recycle on this thing. So I'm just going to unplug everything real quick. Absolute wiring catastrophe on my desk, as you can imagine. Okay, so here's what I'm looking for, is just the daughter card. All you got to do is connect the daughter card just like you normally would when you're powering this thing on. And when you do that, you can come over to the FreeSky, and I'll put a link to this application in the description as well, so you don't have to hunt it down. But you just pick the COM port that becomes available and you hit connect. And when you do that, no port in the flight computer is configured for FreeSky OSD. Well, I wonder if that's the problem. I wonder if something happened during the iNav settings where I lost the where I disabled the FreeSky OSD. That might have been what I did when I was messing around with everything. That might be why I'm not getting a picture too. So let's see. Did I use the FreeSky Smart Port? Oh, yeah, look at that. There is no FreeSky OSD. That must have been what I did. So let's see. I'll just use UART4, and it's right there, FreeSky OSD. All right. I don't know. Can you guys hear me? That was, I don't know what the heck, man. It's like the entire network just stopped working. So I'm going to try and power through this. So it turns out, just doing a quick little reset, it got all the OSD stuff back. So when I was fooling around with telemetry, it looks like I lost the first OSD UART configuration. And just by going back in and doing a defaults, I got it back. So that's where we are right now. And I'll show you what the ports look like to do that. So first key OSD was on UART 6, and then soft serial, we want that to be smart ports. So I want to turn that back on. Then I'll just do a save and reboot, and I'm going to move this all out of the way for the moment and bring the screen back up so you guys can see the screen, because this is what we were after in the first place. Okay, so there's the OSD, and that's kind of what I expected to show by default. So that's the default look at the OSD. And now what I'll do is reconnect the computer. And what I want to show you are the boxes, because this is one of the areas that, again, the reason I'm going through this is because I get asked this question quite a bit on my videos, like how do I get the little scroll boxes over here on the side? So we'll go back into the OSD now. And let's see, there we go, OSD. And the left side scroll bar, I'll set that to, I like speed on the left. And then on the right side, we will show altitude. And I'll hit save and reboot. I'll hit save and reboot here. And when I do that, we'll get a reflash on the OSD. There's the main menu. And let's see here. You see how there are no boxes showing speed or altitude right there on the default? That's why we update the Pixel OSD. So when we update the Pixel OSD, I should be able to get that back. And while we're doing this, I want to make sure I have the chat window. You can still hear me, but it's choppy. Did you turn on Wi-Fi mess up? And I'll tell you what, it's been a comedy of errors tonight, isn't it? Yeah, I'm still getting complaints by YouTube that I'm getting choppy amounts of data, but the network connectivity on my side actually looks okay. I'm seeing virtually no latency and no drops from me to YouTube. So I'm not sure. There's got to be something going on in between this. Anyway, I'm going to press on. So the next thing I'm going to do is I'm going to go back to iNav and disconnect. We'll get rid of that connection. And then I'll bring up the FreeSky OSD app again. So here that is. And I should be able to go in the software and make that visible for you guys right there. So there's the FreeSky app. And I'm going to go ahead and click on my COM12 port and hit connect. And there we go. So when it works correctly, that's what you should see. It reads the fonts in. So once you have this app open, you come down here to Flash Firmware, and it pulls the firmware revision off the internet. You don't have to download it. You don't have to do anything with it. It's just right there. So I'm going to select this, and you can see that it's saying flash or flashing. Martin, you're saying you can't hear anything? That figures. Let me try something else. Test. 1, 2, 3. Test. Can you hear me now? Hello, can you hear me? All my meters look okay, and I hear my monitor sounds okay on my side. So you're still saying you can't hear audio, or you can't hear audio well? Anybody? Audio is all messed up, huh? Okay. Well, all I can do if audio is messed up is restart the damn machine again. So much better as of right now. Okay. So okay, you guys are saying you can hear me. Good, hear you good, good sound. Okay. Working now. Okay. Okay, so what I was talking about was in the Firski OSD application under COM12, and that appears automatically. I didn't have to do anything. And then I hit connect, and then under flash firmware, when you click on that button, it'll automatically populate this field and give you your options. So if you click 2.0.0, it will automatically flash for you. That's it. It's real simple to update the firmware on this Firski OSD. Man, the technology is giving me a kick in the nuggets tonight, isn't it? I think I may have to just make a process of just shutting everything down and rebooting it all before I do any kind of work again. Okay, so I'll disconnect from there and I'll close the app. And since I still have my USB connected to the flight computer, it's real easy just to go back into iNav and hit connect. In theory, it might make me unplug and replug it again. Yep, it doesn't seem to like that. So that's okay. This happens quite a bit with iNav, by the way. You do wind up having to unplug and replug. Man. All right, so let's try that again. Connect. You know, I just heard some really loud noise in my headphones. So something's going on with my audio again. I don't know, man. This is one heck of a night when it comes to the equipment. All right, I'll tell you what, you guys hang tight. I'm gonna come right back. I'm gonna do another reboot because I'm hearing it on the audio as well on my side. When I just plugged in, I got a really loud noise in the headset. I don't know why. Something's going on with the software tonight, but hope audio again. So I can hear it okay in my headset. I'm not hearing any scratchy noises. Okay, so where we left off was I had just flashed the firmware on the Firski OSD. Now I'm gonna bring up iNav and we'll run the iNav flight computer software again, and we'll hopefully what we'll be able to do is check in the OSD and get get the ability to turn those boxes on in the OSD on the side, and hopefully everything will work this time. Boy, I'll tell you what, man, technology has not been my friend tonight. No. Now iNav doesn't want to connect at all. This is awesome. Well, this has just been invigorating. At least I'm not getting nasty audio noises now. Okay, come on. Oh, you know what? I had the battery plugged in. Let me unplug the battery and give this thing a full shutdown. That's probably the problem. Okay, there's a full shutdown. Everything's off now. Try this one more time. I have faith that it'll work, but it is definitely a little kludgy. There we go. It came back. All right, in the OSD, we're back in the OSD now. We'll wait for the data. And once this OSD appears, I'm going to load the font manager and I'm going to pick a font. It doesn't really matter which one. I'll upload the font and there we go. After that's done, we'll get the battery plugged in and hopefully I'll fire up the OSD and we'll see those little boxes we've been after. Normally it's not this hard. Obviously, you know, I've got a live stream going on. I've got network problems that are not cooperating with me. They're throwing curveballs in the mix. So it's normally not that hard. You just connect after you flash your firmware, you connect the Firski app, you update the firmware, and then when you unplug it and replug it, you simply go to the OSD, upload your font, and you'll be in business. It's normally not this convoluted, I promise. Okay, so I'm going to plug the computer back into the battery again, and there we go. Between me and YouTube that I can't see because I keep seeing that I've got an excellent connection. I keep seeing, you know, my data's working, my streamer's working, and then all of a sudden it just drops off to 0. So I'm not exactly sure what's happening here, but anyway, let's cut back to it. What I wanted to show you was that if I go back to the desktop, what I wanted to show was that we finally got what we were looking for, and that was the two little boxes, the little side boxes. So you can tell when you update the firmware, you actually get the side indicator boxes. That's what I was after right there. So speed on the left, altitude on the right. All right, so we've got that, and that's what happens when you update the FirstKey firmware. You get the extra, I guess, extra graphics or extra firmware processing that's required in order to draw the graphics correctly on the screen. So that was one of the main things I wanted to show is that's how you flash the FirstKey Pixel firmware. So there we go. That's it on the firmware upgrade. All right, now hopefully we can get back into iNav and spend a little time in iNav, because now we've kind of conquered all the hard stuff. We've got the receiver working, we got the telemetry working, we did the FirstKey Pixel OSD upgrade. Now hopefully we can go back and take a look at iNav, and I can show you some of the basics that you want to look out for when you start working in iNav, in the iNav configurator. Okay, one of the first things it's going to ask you to do is a calibration. So on the calibration screen, it's a good idea to do this when the unit is out of the airplane. You don't need to do it in the airplane. You just do the calibration, and doing it on the desk is fine. It doesn't need to be done inside the aircraft. Now, if you do it inside the aircraft, there's a good chance that you might be fooling around quite a bit with pitch offsets and bank angle offsets and all that. So I like doing mine on the desktop. So I'll just hit calibration, and we'll go through a calibration really quickly. I'm just going to disconnect my battery. I'm going to disconnect the VTX because we don't need all that stuff. That's out of the way now. And we'll just do a quick little calibration on iNav. Okay. So there we go. I've got it on the screen in front of you, and I've got the calibration screen in iNav opened. Is it time for a 1 hour break already? Yeah, I guess it is. No, yeah, I guess it is. We're right at the hour. All right, so calibrate accelerometer. I'm going to push through it, Lynn, because I've had so much challenge keeping the network up and running tonight that everything seems to be kind of stable right now, so I'm just going to keep going. So on the calibration screen, we're going to hit calibrate accelerometer, and you can see I've got the board setting flat on the table right now. So we'll hit calibrate and then OK. And then all you have to do is put the flight computer in the position that it indicates on the screen. So next step now is upside down. So I'll invert the board and set it upside down just like that. And I'm holding it flat. There's a calibration press. And then it says put it on the side facing toward starboard. Now, where's the little arrow? There it is. There's an arrow right on the front of the unit right there. There's a little arrow. So you just want to mimic that. It's saying put it on its starboard side. So I've got it flat on the starboard side, and I'll hit calibrate again. And then step 4 says to put it flat on its back, aiming straight up. So I will do that, and I've got a pin in the way here. Kind of feels like it. I'm going to move it off screen and put it on the edge of a computer and do it that way. Let's see. It says, oh, I did it the wrong way. All right, that's okay. I'm going to put it up on the glass shelf again and do it up there. I know you can't see it, it's off screen, but all I'm doing is putting it in the position it's showing on the screen. Okay, and now I'll put it in the up position, facing straight up. I'm doing that because I have all these cables hanging off of it. And then flat on the table again, so nice and flat, we hit calibrate. And if everything works good, you get a calibration finish, we hit OK, and I like to save and reboot. Just about every time I perform any significant function on these iNav computers, I like to hit save and reboot. Okay, so now we've done our radio configuration, we've done our calibration, we've got our OSD firmware upgraded. After this, it just starts to turn into some fun. So The next thing we'll take a look at is the presets. So the reason I want to point out presets, I'm kind of surprised that they don't put presets at the very top of the screen. So if you are flying one of these planes like a Z84 wing or an S800 or a mini Drac or a Dart 250, you can pick one of these presets. And when you do, I'll just show you what happens when you pick it. So let's say that this is going to be a flying wing S800. When I click on that, it shows you that it's going to adjust its gyro filtering. It's going to adjust PIDs and adjust rates. So if you want to use the PIDs and the rates for an S800, you can go ahead and click apply on the presets and it'll reboot the flight computer. And then when we go over to the PID screen, those PIDs for known working configuration on a wing will show up and they'll be there. All right, so I'll go ahead and bring up the PID screen and show you what that looks like now. And here we go. We've got feed forward of 49, 52, and 60. And then the P value for roll, pitch, and yaw is at 6. And then the I value 6, 9, and 10. So yeah, they were definitely adjusted just a little bit. So a lot of people don't like to use presets. Personally, I don't like to use presets. When I'm done with this, I'll erase this whole thing and start over. But I just showed it to you because if you're not sure about presets or if you're not sure how they work, now's the time to use them. I don't think you want to spend a lot of time trying to configure the board and then find out that you applied presets and blew away all the work that you did. So anyway, I kind of stepped out of order there and went into presets just to show you that it's a few steps down. And if you choose to use that to help out with your initial setup, you probably want to do that early. Okay, the next thing to do is just go into the mixer, and you can see even though on the presets I picked that it was a flying wing, nothing is set up on the mixer. So on the mixer tab, this is going to be a flying wing. It's basically a plank. It's the Strix Goblin. So effectively it's a flying wing. It only has the aileron and elevon control surfaces. So I will select flying wing, and then I'm going to hit load and apply. And what'll happen when I do that is it'll set up the mix for me. It'll set up the mixes for me. And the only thing that I'll need to do after that is when I start connecting servos and doing my testing, you just need to make sure that the mixer is operating things in the right direction. And if not, you can come into the weights and invert the weights. So for example, if I go on this aircraft and pull the elevator back down toward me, so up elevator, and this servo is going the wrong direction, I can just simply invert it. So you invert it by putting a negative value in, and that'll take care of that. One other thing they do in iNav for some reason I'm not sure about is they like to put in 2 motors. I don't know why that's the default. I don't know how many. I mean, if you think about flying wings, most of them don't have 2. They mostly just have 1. So I'll just delete that and I'll leave it set up with just 1 motor. So anyway, this is the mix setup for a flying wing. Very traditional mix setup for a flying wing. The important thing about iNav to understand is you don't do a mix on your radio. You just do the standard 4 channels, and iNav will handle the mixing for you. So once you've got that set up the way you want, go ahead and hit save and reboot. And then the last big thing you want to do when you start getting into testing is making sure that you enable your servo and motor output, because if you don't turn that on and you try and do your testing, it won't work. You won't see your servos move. And when I first started fooling around with iNav, it took me a while to figure out, why aren't my servos moving here? Why isn't my motor moving? So there's just an option under outputs to turn that on. And then you can also do some testing or calibration of your ESC by using this master slider. That's a little outside the scope of the video, but I wanted to show you this screen because this is where you kind of see, and I'm moving my sticks here, this is where you see what your outputs are doing. So you can see how far they're traveling, what happens when you pull elevator, what happens when you push on the elevator stick, what happens when you operate your ailerons, and if you move your throttle, what would happen there. So and here I can turn on enable motor control right here. So if I wanted to do motor testing or calibrate my ESC, you can turn that on as well and enable the motor control by using this little slider. Okay, ports. I kind of touched on ports already, but ports is where some of the main configuration happens with regard to what you're connecting to the iNav computer. So default UART 6 is used for the Firski OSD. Somehow along the line, when I was working on the soft serial, I must have made a change, or I just lost the configuration. So channel 6 enables the Firski OSD. USB, VCP, and UART 1, it's really not a good idea to change those. And then UART 2, I'm not exactly sure why, but iNav recommends strongly putting the receiver on UART 2. I don't know if there's a priority thing going on there or what, but they do recommend that you use UART 2 for your serial input on your receiver. So if you have other things that you're going to connect, like an airspeed indicator or a MAVLink controller, if you're going to use optical flow sensors or a rangefinder, you can configure all those items in here. If you want to connect a smart audio or IRC tramp for VTX control, you can also configure that in the ports section. All right, configuration. This is where you do the basic configuration for the general parameters of iNav. So the I2C speed, they recommend setting it to 800 kilohertz if the hardware connected supports it. In my experience right now, just using a standard GPS and no other peripherals, 800 kilohertz on the I2C bus seems to work just fine. And then also notice that when you flash the 2.6 firmware, the barometer shows up with the correct version DPS 310. That is the correct chip on the Matek F722-WPX. Also notice that for some reason they're registering a pitot tube, and you can see up on the top of the screen they've got a speed indicator up here. I don't have a pitot tube, so I'm just going to disable that and set that to none. I also don't have a rangefinder, and I don't have optical flow. Also, since I am using GPS, I need to turn that on, and I think that I must not have enabled it in ports, but let me go ahead and enable it in ports first. Let's see, peripherals, and I connected it to, I'll have to look at the wiring diagram just to see where I connected it. 1 second here. Yeah, it's really important when you start configuring these things to go ahead and just set up a bookmark to the wiring diagram, because you'll be referring to it quite a bit. So I just want to make sure I get the right one here. And I used number 3. Okay, so my GPS is right here on the number 3 UART. So I'll come into number 3, and under sensors, it's GPS. So I'll hit save and reboot on that one. So UART number 3 has my GPS. And when I do that, I expect the GPS indicator won't come on until I tell the configuration it's using GPS as well. So there's how you tell it what UART it's connected to. And now that I've done that, when it reestablishes connectivity, I should be able to go, and there it is. It's still enabled GPS. That's good. So I'll go into configuration and enable GPS. Enable GPS for navigation and telemetry. For protocol, U-Blocks, at least for the BN series, the 220 and the 880, U-Blocks works. If you want, you can set ground assistance type to auto detect. And then if you want to go ahead and turn on Galileo satellites, that's the EMEA or EU satellite system. I'm in the US, so I really don't need to do that. Time offset in minutes, I'm -5. So that would be 300, it's 60 minutes, so that'd be 300 minutes for me. I'm not sure if that's -300 though. And I'm going to go ahead and turn on daylight savings time for the US. So I'll hit save and reboot. Now when it reestablishes connectivity up on the top for iNav, are we not seeing iNav? The browser's in the way. So now we have the blue GPS puck right at the top up here. So there we go. And I think I just had the browser covering. So let me go back to the configuration page and show you the changes that I made in there real quickly. So all I did under GPS is turn this switch on, and under protocol I selected U-Blocks, and under ground assistance type I set it to auto detect. I set my time zone to be a 300-minute offset, and I set automatic daylight savings time to the USA. That's it. And then I hit save and reboot. And now I've got a blue GPS up top, which is what you want. And then the last major thing that I'll show you is failsafe. So you want to come in and set failsafe, in my case, return to home for fixed wing. So I do want it to be return to home. And of course, before I leave this page, it's going to hit save. I'll hit save and reboot. And under advanced tuning, I want to do a couple of things in return to home mode. Under return to home altitude, there's a couple of different options. I'm not going to go through all of them tonight, but there's a couple of different options you can choose here. I recommend reading the book and deciding which one you like the best. At least linear descent are good options for people who are flying in a flat field or a flat area. If you're flying around mountains, you might want to look at the extra or at least, max options, depending on your flying and where, if you have mountains or obstacles in your way. Where I fly, at least is a good enough one for me, because I know that if I'm at 350 feet, I'm basically over top of everything. And then the other thing that make sure you want to check under return to home and landing settings is land after return to home. I always turn that off for fixed wing. If you have a very large field, you might be able to use that. But if I have a return to home scenario, I'd really just rather have the plane come back. And it's going to loiter. So for some reason, I can't get radio control back. It'll wind up doing a landing anyway, because it's going to run out of battery. But on land after return to home, I'm going to set mine to never. And then the other thing you want to check into is your altitude at return to home. So they have return to home. Let's see, where did it go? Here it is, return to home altitude, 5,000 centimeters. And then the return to home altitude, if you want it to loiter at a different altitude, you can set that here. So once you've got that kind of ironed out, you hit save and reboot, and there we go. So those are really the major elements on the initial setup that I wanted to cover with you guys. I wanted to show you how to get your telemetry working, how to connect your S port, how to update your firmware, how to flash new firmware on the board, how to go through the basic radio setup, and your aircraft type setup. I thought that was really important to cover as well. So that's where I'm going to stop in terms of the iNav configuration. I don't want to turn this into a full iNav clinic, because as you can see, we would be here for hours looking at every single one of these different options. So I think from there, the thing you want to do is start reading the book. Get into the book, start reading the help, and trying to figure out what all these different knobs and dials do. And just understand that the developers, before you go in and start changing things, understand that the developers normally have a pretty good reason for selecting the values they select. So if you want to make changes, I'm not saying you shouldn't. I'm just trying to suggest to you that you make sure you understand what you're doing and why before you actually make those changes. So with that, I'm gonna go ahead and disconnect from iNav and shut that down. And I'm gonna bring the wiring diagram up real quick. And yeah, it looks like whatever was going on with those glitches, they've pretty much cleared up since then. I really don't know what the heck is going on. I don't know what happened. That's very frustrating though, when you're trying to put a show together and the network doesn't cooperate. And you know what? Let's see. Let me go ahead and bring up this incognito window. There we go. And I think I mentioned a little bit earlier, I'd take another look at some of these other configuration options. So Crossfire, if you look at the wiring diagram, they show you how to connect the different types of receivers right along this edge. So you can see I've got S-Bus, F-Port, Crossfire, and PPM, or iBus if you want to use iBus. And I think that's FlySky. I think that's FlySky's protocol. Also notice over here on this side, they've got dual camera connections. So you can have camera 1, camera 2, and your VTX. And then they show you your wiring diagram for your GPS. And if you have a daughter card, if you're using the Matek VTX, and of course, if you have multiple ESCs and battery connections. One thing I do want to point out very carefully here, guys, is that make sure when you connect your ESC on the signal side, do not run power to from the ESC to the board. You really, in fact, they put it in bold right here. They say, do not connect the ESC onboard BEC output red wire to the RX1 pad. So make sure before you connect your ESC to the flight controller that you disable that center voltage lead on your ESC. Don't connect it directly to the Matek flight computer. All right. They do have, just so you know, the reason for that is because the Matek flight computer already has BECs on board, and you just don't want to have another voltage loop or current loop possible by feeding voltage in from an alternate location where it's not expecting it. All right. Well, Hola chillin'. I appreciate that comment, man. That's very nice. And I'm really sorry about the difficulties. I really don't know what happened. I've been looking at my network ever since then, and it's just been rock solid. So I just don't know. It's just one of those nights. I mean, even the computer, even the computer didn't want to cooperate. It took a couple of different reboots. I lost the OSD, but that it's kind of good, I guess, to see that kind of thing, because you got to understand when you start fiddling around with this kind of thing, it's not perfect, right? It's just not a perfect piece of software, and it's not a perfect environment. So it does take a little perseverance. You have to spend a little time saying, okay, well, what's going on? Like the OSD thing, to me, that should have just worked. I don't know why it didn't, until I started when I did the firmware update and it said, hey, there's no OSD attached to that card. Well, that's when it dawned on me that somewhere along the line, that port configuration got blown up. So just doing a flash or resetting to defaults got it back in order. So yeah, that's right. Gremlins, Lynn, that's right. They do exist. And I'll have to go back and look at the video and see if there's anything that I did to change it, but I really don't recall changing that UART off of first key OSD. So anyway, the cool command to learn is defaults. And then the other thing you can do too, if you guys want to see, I kind of mentioned this. I said I'll erase everything. Let me go ahead and show you that little trick too, because that's one of the cool things about iNav. If you don't like what's going on, you can always just start over. So, and I'll be honest, I've started over more than once. So let me get this browser window out of your way. And I'm going to disconnect the flight computer now. So there it is on the window. And remember how we started in DFU mode? We just press this button. Well, first off, if we connect it and we go into the CLI, and there's my beeper is beeping at me. So if we go into the CLI, we can just type the word defaults and that'll blow it away. So if we just type defaults down here and hit enter, it's going to reboot, and that's it. Everything that we did until now is going to be gone. And it should come back up when it reboots. It should ask, hey, what kind of flying? Yeah, there it is. So that's how you know when you see this window, that's how you know it's fresh. And if you ever not sure that that's doing what you needed it to do, the next thing you can do is disconnect it, and then when you disconnect it, press that button right there. That's the DFU mode button, and then plug it in again. And you'll know right away if you're in DFU mode because it says so right up here. So once you're in DFU mode, you can come back to the firmware flasher, pick your board again, and we'll do the Matek F722-WPX. We'll pick a firmware, and you see this little option here. It says full chip erase. When you hit that, and when you say flash firmware and that little full chip erase option is set and you hit flash, that's it. I mean, that's like basically like formatting your hard drive and starting over. So if you're not sure about what you did, or if you want to go back, or if you just want to practice the steps, that's sure one way to do it. One thing I'm curious about though is I wonder if doing that erases the Pixel firmware. I don't think it does, but we can check. I know one quick way to find out. And that's by putting the VTX on the board. I'll do that, and then we'll bring the monitor back over, and I'll just have to, when it reboots and comes back online, I will have to set those boxes. That's how I know the Pixel firmware updated is those boxes on the side. Everybody likes those boxes. Okay, so it rebooted. It's not in DFU mode anymore. So I'll hit connect. We're back. Connect power. And I'll bring the monitor. I'm going to switch over to the big screen so you guys can see the monitor. Let's see here. Big camera. And then I'm just going to go into the OSD. And I will set the left scroll bar to be ground speed and the right to be altitude. Yeah. So you can tell right there when I turn those on, you see how those boxes just popped in right there. That means the flashing of the firmware, the iNav firmware did not. And I can always tell because those show up when you get the new Fursky Pixel OSD firmware. Oh, good. Just in time to start dropping packets again. That's awesome. All right. Well, I think that's it, guys. I think we're at the end of the material that I really wanted to cover today. And use the correct target firmware. Yeah, Lynn learned that lesson the hard way because he was doing some work with his iNav flight computer and he wound up flashing a hey, you know what? I'm going to have to make a confession in just a second. I think I might have realized what just happened. But anyway, Lynn brings up a good point. He says, make sure that you use the right firmware for your board. And it's a good idea to understand what model board you have. And also making sure that you're probably not on the bleeding edge of firmware either. For a flight computer, that's not a place I really like to be. I like to be backed off just a little bit. So anyway, what I was saying was I might have to make a little bit of a confession. When I pulled the monitor in, so I don't know if you guys realize what happened tonight, but because I was doing a technical live stream, I pulled my camera way over to the side, basically my computer is right there. And I realized when I brought this monitor in, I had antennas sitting right over that computer, and I'm kind of wondering if they interfere with my network connection. It's possible, I guess. Anyway. Decompiler says, I just tried iNav on one of my 6-inch quads, got toilet bowl on GPS hold, think I need to get my mag away from everything. Yeah, you need to get your mag away from everything, and you need to probably do a little reading on PID tuning. Boy, I spent a lot of time on PID tuning, and I think that's probably an area that I'll probably continue to invest, making effort trying to make sure my PIDs are set up correctly. But yeah, PID tuning is definitely a thing on iNav. You have to be willing to do that kind of work. So anyway, again, I'm kind of at the end of what I wanted to cover. So I thought before we break, it might not be a bad idea just to check and see if you guys have anything that you'd like to talk about. Is there anything on your mind about iNav that you'd like to know about? Is there anything that I didn't cover that you'd like to see specifically? This is a really good opportunity to do it, because I've got the computer set up right here in front of me, and we've got the time, we've got the live stream going, and it looks like we're not dropping packets anymore. So if you guys have any questions, or if you'd like to see anything in the configuration, it'd be really easy for me to do that. So I just want to make sure I offer that in case you'd like to, in case you'd like to see something specific. So let's see. Decompiler said earlier, computers are made by people. People make imperfect software. Yeah, I'll tell you what, man. I really feel bad about what happened tonight. I don't know. It's kind of a bummer. It started out with the radio telemetry, like right off the bat. I don't know what happened with the radio telemetry, but I've never had that kind of problem before. I've kind of monkeyed with this before on my other boards, and it just pops right up. I've never seen a scenario where I couldn't get the telemetry just to key right in. So that was kind of weird. Lynn says, use the correct target firmware. We covered that a little bit. And that's it. So I guess, I don't know. Is there anything else you guys would like to see? Is there anything specific in the configuration you'd like to see, or anything in the calibration or the advanced config under modes? I don't know if you guys have ever looked at modes. I think most people that have done beta flight or any form of clean flight or iNav have seen modes before. So that's why I kind of skipped over that a little bit. I'm interested in the GPS waypoint configuration on that setup if possible. Yeah, we can do that. Let's do mission control. So we go under mission control and it says Arlington South. Let me see if I can find my field. I don't know what map that is. There. Oh yeah, that's near where I fly. Let's see. There it is. I found it. Okay, so there's my flight field. All right, so waypoint configuration. The way this works, real simple actually, and it's actually this is one of the things I want to do eventually is do a couple waypoint missions. But here's my flight field. So let's say that while I'm out flying around, I do an auto launch and I have it loiter after taking off, right? And one of the cool things, by the way, about auto launch is that if you touch the sticks after auto launch, then it goes to whatever mode you have configured. So one of the options that you can use is do auto launch, have your mode switch set to loiter, and then do an auto launch, let the plane take off. And as soon as you see it climbing out and everything looks graceful and under control, just bump your stick. And as soon as you bump your stick, it'll loiter. Not a bad idea to let it climb and get a little altitude first, and also you want to make sure that your loiter mode works correctly too, by the way, make sure that's true. But anyway, so let's say we're at the field and we want to do a waypoint mission. Here's the way it works. On the field that you want to fly in, you simply just, you click. So I'm just going to click on a location and you can see that it dropped a waypoint. And if I want to move that waypoint, I can move it. I can add one. I can add one here and then another one here and maybe another one over here and then another one here. And then you can also go back to a waypoint and say what you want to have happen at that waypoint. So this waypoint, here's the lat and long. I can set an altitude and a speed. And then you can do that on a per waypoint basis. And once you've got everything set the way you want it, you can move these around. Say you want this one to be maybe the approach end of your runway, for example, and then the last one you want to be in the middle of your field. Once you've got everything the way you want it, you can do a save EEPROM mission and a save mission to flight controller. And I'm going to, in the spirit of full disclosure, I haven't tested the two of these yet. So I'm not exactly sure what the difference is on the two of them, but I do know that there is a way in modes to enable a waypoint mission. So I have the feeling that if you save EEPROM mission, it probably survives things like reboots. And if you save it to the flight controller, it seems to me to be a little bit more dynamic. But again, I haven't done my homework yet on the difference between the two. So you can just hit save mission to flight controller. And then when you leave this screen and come back, you can load that mission from the flight controller. And I'm pretty sure when you go into the waypoint mode, this is what will load up, is the one that you've saved to the flight controller. And then the one other option to do as well is return to home at the end of a mission. So putting return to home at the end of the mission, you can save that as well. And after this waypoint is reached and loitered, the aircraft will come home and circle. So just another option. All right. Lynn says the station. I'm not sure what that means. Decompilers, RPM filtering really not recommended on iNav. I don't know the answer to that on RPM filtering. I don't know. I don't even know what that is. So that just goes to show you. And by the way, I spent a lot of time in iNav, so I'm not exactly sure what RPM filtering is. That sounds like it might be quad related, but yeah, that's I'm not sure what that means. Oh yeah, I need iNav, thank you. And FYI, there's around 60-second delay from chat to you. Yeah, that's normal. Well, 60 seconds seems like a lot, but normally it's about 12, I think, is the normal delay that we see on chat. And like I said, man, several times, there's definitely something going on in the network tonight. So, although right now everything looks really healthy. YouTube is still complaining about not receiving enough video to maintain smooth streaming. And I'm not sure why. My side, it shows really strong. I'm showing that I'm pumping in 53 kilobits per second right now, 5,300 kilobits per second. So I don't know. I don't know what YouTube's complaining about. Anyway, so yeah, there's your waypoint mission if you want to run it. So, and if you don't want it, you can just hit remove all points and they're gone and you can start over. So any other questions for me? RPM filtering, sorry decompiler, I don't know what that is. If that's a quad thing, that would explain why I don't know, because I've only used iNav on fixed wing so far, so I'm not sure what RPM filtering is. I would have to spend some time on Google with that one. All right, I don't see any other questions. Is there anything else you guys want to see before we turn this one off? I think it's been, again, I really sorry about the technical challenges tonight. I appreciate those of you who stuck with it and hung with me and encouraged, so I appreciate that. But hopefully the material will be out there for a while and you can use it for reference if you need to. And appreciate the intel, looks good over here in California. All right, good. All right. Well, hey guys, again, I appreciate you sticking through it. I know this was a bumpy road tonight, so I appreciate you hanging with me. And unicorn filter is what you want on quad. Says Nadies. What does that say? Nady Cell Girl. Unicorn filter is what you want on quads. Okay. Unicorn filter. I haven't heard of that one. What can I use to maintain altitude other than GPS? LiDAR and barometer. There's actually a configuration option in here under advanced tuning, I believe, that'll show you the weight that it places on the different variables. So vertical position barometer weight. So you can increase the weight on the barometer. In fact, the barometer is probably the better option, right? It's the GPS updates are too slow, so I think that's why they use the GPS weight with a low value, and the barometer is a higher value because the barometer updates come in quicker. So if you have barometer on your board, that's the one that you want to use for altitude updates and fix. GPS, I've heard complaints about GPS that it just updates too slow. And when it does update, the movement of the craft gets very choppy. That's what I've heard. In my case, all I've ever had is GPS and barometer, so I don't have any other sensors. I haven't used LiDAR. And I also think LiDAR is only good. I believe it's only, you have to be within a certain altitude of the ground for that to be effective, I believe. Don't hold my feet to the fire on that, but that's my understanding of it. Auto launch is a good topic. Yeah, auto launch, by the way, let's talk about that. They move the auto launch settings into advanced tuning. And all I can say about auto launch is that it probably takes a little bit of tweaking. And I have a feeling that their thresholds are just a little bit high. I don't have the values that I used in my other computers in front of me. What I'll do is after the video's over tonight, I'll get my auto launch settings out of my NanoTalent and I'll post them in the description for you guys. And I can tell you that my auto launch settings for the NanoTalent work very well. On my Mini Talon, not so much. I still have to go back to the Mini Talon and make those adjustments. But the auto launch settings are moved now out of the CLI and into the advanced tuning tab. So idle throttle, I don't think you ever really want to set that below 1000. I'd leave that there. The max throw angle, I think 45 might be a good idea to, it says if you look at the help, you can disable it by setting to 180 degrees. I think it's probably not a bad idea to increase that a little bit. Maybe I wouldn't get too crazy about it, but I think one of the only reasons I had a failure with my NanoTalon is because I launched it at way too much of an angle, like the nose was way too high up. So by adding a little extra angle in there, probably not a bad idea. The threshold velocity, if you hover over the help, it says this is the forward velocity threshold for swing launch detection. I guess that's if you have it by the wing. The threshold acceleration, 1863, that's what I leave mine on. I think I did lower my threshold velocity to 150, but like I said, I'll put my configuration in the description for you. The motor delay, I know I lowered the motor delay a little bit. I think I cut that in half. The reason I say that is because you have to throw these planes pretty sharply to get that motor to trigger. And if that motor delay is too long, you can lose a shocking amount of altitude before the motor kicks on. The launch throttle, it's 1700 microseconds. That's pretty much near the top for the default nav modes. So you look right over here, there's a max throttle. This is for nav mode. It's set at 1700 by default. So 1700 is pretty close to the top. Climb angle, they defaulted at 18 degrees. I think on mine, I think I wanted to set it to 20, just something a little bit higher. 18 is a very shallow, but it's very comfortable. It's a shallow climb angle, but it's very comfortable. Launch timeout. This is how long it takes before the launch sequence is actually executed. If you haven't performed it by that time, the launch mode is turned off and regular flight mode takes over. Maximum altitude. This is a limit on how high you'll allow the plane to go under auto launch, and then the transition time in milliseconds. And that the idea behind this was to allow for a smooth transition to flight. So if you have an auto launch and you don't use that transition time, what happens is it kind of jerks. It goes from a climbing angle to flat. And by putting in a little bit of a transition time, it allows the plane to kind of ease into straight and level flight instead of just jerking into it. So that's my understanding what that's for. Decompiler asks if a magnetometer is beneficial or not for fixed wing. Absolutely not. Turn it off. My very first flight with iNav, I used a BN880 with a magnetometer. I know the magnetometer is calibrated correctly because I went through it at least 3 or 4 times. And on my very first flight, what happened, I looked at the video and the heading never changed. And again, it's fixed wing. So the heading never changed from, I want to say it was like 280 to maybe 010, even though I was running in a 360 degree circle. So here's what happened. Because it wouldn't change, it basically went into the emergency land mode. It couldn't get itself closer to home, so it just started circling and dropping its altitude slowly. When I realized what was going on, I took control of the plane and flew it back. But honestly, with a fixed wing, there's no real reason to run a compass because the assumption with fixed wing is that it's always flying forward. So it's always going in a direction that's led by the nose of the aircraft. And for that reason, they can calculate a fairly reasonable heading on fixed wing. And compass is really only a thing for quads because quads can fly in any direction. They can fly backwards, forward, left, right. So a compass heading is a little bit more meaningful for those, but you definitely do not need it for fixed wing. So my personal experience is turn it off. If you have a compass on your GPS or wherever else, turn it off. Just don't even bother with it. I had much better results managing course without the compass and just relying on the GPS only. All right, cool. I smacked the plane into a hill and trying to make my plane smarter about terrain. Yeah, I've been there. In your case, then you probably want to look at things like your return to home altitude mode, and you might want to say extra, for example. Again, I don't have the book in front of me, but extra, I believe extra means it's 300 feet above whatever the current altitude is. Fixed is just a straight up fixed number. Max, I'm not sure what max is. I'd have to read the book on that one. And then at least is just saying, if you're at 600 feet and you hit return home and your return to home altitude is 3, nothing will change. It'll just fly home at 6. So, and then when it gets home, it'll descend down to its return to home altitude. So that's what at least means. It means at least go to say 300 feet and fly home at that. But yeah, if you're flying around with mountains, you probably want to look at extra or max. That's what I'd be looking at. Loiter radius. This is another one that I actually haven't had a chance to go test yet, but I actually reduced my loiter radius on my Nano Talon and then wound up putting it back up there because it wasn't performing the way I liked it. It was a little bit soft on altitude management with loiter radius. So I ended up cranking it back up to the default of 5,000 centimeters, and we'll leave it there. And I do need to get back out and fly that Nano Talon, but loiter radius is another one where I think if you tweak that too much, you might induce behavior that you don't like. That's the bottom line. All right, guys. Any other questions? Anything else about iNav that we need to cover that you guys would like to see? I don't see any other questions in here other than the one about RPM filtering that I don't know the answer to. So, all right. Well, listen, thanks again for joining me tonight. Thanks for being patient as I work through the technical issues with the live stream. That's the nature of live stream. You know, when you do a production video, you can crop all that stuff out. So you have any kinds of problems at all, you just crop them out and you upload a nice little production video. It's nice and tidy, but it's nowhere near as interactive. So that's why I wanted to try this live tonight. Well, I hope you guys appreciated the video. If you did and you're not a subscriber, make sure you hit that subscribe button and a notification bell. I'd like to say thanks to my patrons real quick. Thank you guys for helping out and supporting the channel. If you'd like to join me on Patreon for as little as a cup of coffee in a month, you can help contribute and make sure I've got plenty of equipment and material to review going forward. So if you're in the mood to help out, you can do it for as little as $3 a month. That's all I've got for tonight. Take it easy.